we are a day behind since I let y'all have Tuesday to finish the test and any missing unit 2 work. So let's change the date on this. Because today is not the 25th. Today is the 26th. Okay, so today we're continuing talking about absolute value, but yesterday we talked about transformation rules, writing the equations given the transformations with that A, H, and K. What we're going to look at today is the equations given. Okay, so we have these absolute value equations. We want to be able to solve them. We want to find the variable. Okay, so we need to recall that absolute value is the distance a number is away from 0 on a number line. Okay, so it does not matter if we go to the left into our negative values or we go to the right into the positive values. The distance remains the same. Okay, so solving absolute value is as easy as working with a linear equation, except you're going to have to split it into 2 because we could have gone to the right, we could have gone to the left, we don't know because we're talking distance. Okay, so for instance, I think that's worded wrong there. I'm going to change that. Instead of saying the absolute y equals the absolute value of 5, this needs to be the absolute value of y is 5. So we need to change that. Okay, so what this is saying is if we want to know what y is, we want to know what value, when we take the absolute value of it, gives us 5. They're telling us the distance is 5. So it could be 5 to the right. It could be 5 to the left. Okay, so that means that input value, that y value, could be positive 5. It could be negative 5. Does that make sense? So the input itself, what's inside the absolute value, could be positive or negative to get a positive output. With me so far? Okay, so when I have an equation and I want to solve, the first thing I always want to do is isolate the absolute value, the term or the expression with the absolute value. Okay. So in number 1, okay, what I'm trying to isolate is this term, absolute value of x. Okay, so when I say isolate, I mean move anything else to the other side of the equation. If you need to draw the line down to separate the left and right side, draw that line. How am I going to move that minus 15 to the other side? Okay, so I'm going to add 15 to both sides because what I do to one side, I do to the other. And I'm adding because it's the opposite and we want it to eliminate from the left. So I have isolated my absolute value and I get 4. So there's 2 possible answers. What would they be? What could x be? When I take the absolute value of it, it gives me 4. Think about that number line. Where on the number line could I be? And I would be 4 units from 0. Yeah, I could be at positive 4 or I could be at negative 4. Those would both be 4 units from 0. Because remember, that's what that's telling us. Okay, so this could be 4. It could be negative 4. Now, when you get your solutions, just like with any other type of function, you can always check your answers. Okay, so on the majority of these, I'm going to show you checking your answers. Check the solutions that we think we got. So we think we write the original equation, and we think that 4 should work. So I'm going to input that 4 and I'm going to check. I'm going to evaluate this. So the absolute value of 4 is 4. And then I've got 4 minus 15, which is negative 11. Is that what it was supposed to equal? It is, right? The right side was negative 11. So 4 does work. So I know 4 is a solution. Okay, and now I'm going to double check negative 4. Okay, so I have the absolute value. Minus 15 equals negative 11. And this time I'm plugging in and checking negative 4. Well, the absolute value of negative 4 is what? What's the absolute value of negative 4? Positive 4. Yeah, the absolute value is always going to come out positive. So I've got 4 minus 15. That, again, is negative 11, which is it's supposed to be. So those both check out. So we end up with 2 solutions. Okay, so pretty straightforward when it's just the variable in the absolute value bars. You isolate it and then you set it equal to the positive and negative value you got over here. Okay, but what about here, like in number 2, where there's more than just the variable inside the absolute value bars? The absolute value portion here, when I say to isolate it, it's already isolated. That's it. There's nothing outside of it, is there? So we have isolated it already, or it was given to us isolated. So what we do now is the same thing we did right here. There's just more to it. Because here we took what was inside the x and we set it equal to positive 4 and we set it equal to negative 4. We're going to do the same strategy over here. We're going to take what's inside, but this time what's inside is 6u plus 9. And we're going to set it equal to positive or negative 3. So positive 3 and negative 3. So do y'all see that that's the same thing we did right here? It was just here, the inside was just x, so we were done. Here, our inside is 6u plus 9. So now we've still got some work to do. So far, so good? All right, if you need that line to separate the equation, draw that line if you need it. So I'm going to solve for u by subtracting the 9 over. And you'll notice it's the same steps on both of these. Okay, we're moving the 9 on both. Okay, now over here, that leaves us with 6u equals negative 6. And over here, that leaves us with 6u equals negative 12. So then we divide out the 6, the same step on both of these. So here we get u equals negative 1. And over here, we get u equals negative 2. So now I'm going to check that those both work. So it is the absolute value of 6u plus 9 equals 3. So I'm going to plug in a negative 1. We're going to see if negative 1 works. So if I plug that in and I evaluate, I've got 6 times negative 1, that's negative 6, plus 9, and that's all still in the absolute value. Negative 6 plus 9 is 3. What is the absolute value of 3? What is the absolute value of 3? It's positive 3. When we take the absolute value, it's always positive. So that is 3. It checks out. That came out to 3, which was what it was supposed to come out to up here. Okay, but now I'm going to check, what if I plug in a negative 2? Is that one going to work? So I'm going to plug that in. See if this also evaluates out to 3. So I plug in a negative 2. Oops. Why are you not writing all of a sudden? Okay. Sometimes I wonder, there's a joke being played on me with how often I have technology issues when I'm trying to record a video. Okay, we're plugging in -2. Here we go. All right, 6 times -2 is -12 plus 9, and it's all still in the absolute value. -12 plus 9 is -3. What is the absolute value of -3? 3. Is that what it was supposed to equal? Yeah, it was supposed to equal 3. It checks out. So both of those solutions are good. So I end up having u equals -1 and -2 as my solutions. Okay. So over here, we got 4 and -4. So sometimes our two solutions will be opposites, but sometimes they won't. -1 and -2 aren't opposites. Okay, so just be careful. Don't make any assumptions on what you think it should be. Okay, actually work it out. All right, let's take a look on the back. Here's one that looks a little different. Why is this different on number 3? What do you notice that's different about this than what we did on the front? Yeah. So the absolute value is already isolated, right? Absolute value of 3x plus 18. There's nothing outside it that needs to move over. So on the front, when I isolated, I had equals 4 and equals 3. And so I was able to split those to +4, -4, +3, -3. Can I split a 0 to +0 and -0? No, that's what's different here. Okay, this is a special case because this is set equal to 0. Okay, so I'm going to make a little side note up here. 0 does not have a sign. 0 is not positive or negative. So there is only going to be one solution. Since the equation equals 0. It's because of that 0 there. When you isolate the absolute value, if it's set equal to 0, you can't split it into a positive and a negative and solve twice. There's only going to be one equation to solve. So I take the inside, set it equal to 0, and solve. Again, if you need to separate the left and right, let's do that. And now we're going to subtract 18 from both sides. And then I need to divide out the coefficient, 3 in this case. So I get x equals -6. Now I do want to check my solution works. So I've got the absolute value of 3 times something plus 18, and it should come out to equal 0. So we think the answer comes out to -6. So we're going to check -6. We're going to plug -6 in and see. So 3 times -18, or excuse me, 3 times -6 is -18. Okay, we've got plus 18. That comes out to 0. And lo and behold, the absolute value of 0 is indeed 0. So it checks out. -6 is our solution. Good? All right, does anybody notice anything different about number 4 compared to the ones we've done so far? Yeah, it's negative. So our absolute value is already isolated again. We've got our absolute value term or expression, and it's set equal to a negative. Okay, on the front, when we isolated, it was set equal to a positive, and here it's negative, but it wasn't isolated yet. Once we isolated it, it was equal to a positive. The thing is, the inside, we move it, we separate it and set it equal to a positive and a negative. But that's the input. The output is what you set equal to over here. Your output for absolute value cannot be negative. Okay, come back to that number line. We said the input, y in this case, that can be positive or negative to get a positive output. There's no way to get a negative output when we do absolute value though. So this is another special case. Okay, so I'm going to put a star above this one also. Okay, because of that negative, okay, there is no solution. Since the equation equals a negative. Now, somebody in an earlier class said, what about number one? Number one was equal to a negative, and we did it. Let's go back and look. So number one started out equal to a negative, but it wasn't isolated yet. We're talking about once we isolate the absolute value. So here, when we got absolute value by itself, it was equal to a positive. Do y'all see the difference? It's once you isolate the absolute value equation, if it's set equal to a negative, then there's not going to be a solution. So my answer here, I would just say no solution. There is nothing that I could plug in for y and solve this and get a -6 as the absolute value. Nothing. Okay, so those are two special cases. If you isolate and it's set equal to 0, one solution. If you isolate and it's set equal to a negative, no solution. Otherwise, you should have two solutions. Let's try number 5. The absolute value expression is not isolated yet. There's a 6 out front. How am I going to move that 6 across the equation? That 6 is being what? When it's up against that, it's multiplication. Just if it's up against a parenthesis. So that 6 is being multiplied. So how am I going to move it? What's the opposite operation of multiply? Okay, so I'm going to divide by 6 so that it eliminates on the left. And what I do to one side, I do to the other. So I end up with v minus 3 as the absolute value equals, what's 54 divided by 6? 9, good. All right, so now I've isolated, okay, and it's set equal to a positive. That means I'm going to have two solutions. That's good. So I'm going to split this. I'm going to take the inside, which is v minus 3, and I'm going to set it equal to positive 9, and I'm going to set it equal to negative 9. And now I'm going to solve both of those. Okay, both of these, you can split the left and right if you need to. Okay, but the step to get rid of that minus 3 is to add 3 to both sides. The same step on both. It's just going to give me a different outcome. Here, v is going to equal 12. And here, v is going to equal -6. Now I can check to make sure both of those work, make sure I didn't make any mistakes anywhere. So 6 times the absolute value come out to equal 54. So I'm checking first 12. So inside, we do inside first. 12 minus 3 is 9. So we have 6 times the absolute value of 9. The absolute value of 9 is 9. So it's just 6 times 9. And 6 times 9 is indeed 54. That's what it was supposed to equal. It checks out. So then I check, all right, does negative 6 work? So if I plug in negative 6, negative 6 minus 3 is negative 9. So I have the absolute value of negative 9 times the 6. The absolute value of negative 9 is positive 9. And again, 6 times 9 is 54. So it checks out. It was supposed to come out to equal 54. So that means 12 and negative 6 are both solutions. All right, on number 6, I need to isolate the absolute value expression, which is the absolute value of m minus 1. How do I get rid of that 2? I'm not going to distribute. The absolute value are not parentheses. Say it again. I'm going to divide it over. Okay. So I'm going to divide. So I've isolated the absolute value of n minus 1, and I get negative 9. Is that possible? When I isolate my absolute value, can it ever equal a negative? No, that's what we just said on number 4. We said this is a special case. You cannot equal a negative. Okay, this is not possible. It cannot equal negative. So there is no solution here. I'm glad you mentioned, though, distributing, because that's a common mistake. And when we have absolute values, some people want to treat them like parentheses. In some aspects, they're like parentheses, like working inside first. Okay, so in order of operations, you work inside the parentheses first. That part is similar because you work inside the absolute value bars first. Okay, but you cannot distribute into them like parentheses. So just be aware of that. Y'all feel okay about these? So you're either going to have one solution if it's set equal to 0, no solution if it's set equal to a negative, or 2 solutions if it's set equal to a positive, once we've isolated that absolute value. Okay, so you've got practice. You've got the rest of class to practice this. Let me pull it up here. It is in Delta Math. So if you go to your Delta Math, let me get student view. You should see 2 possible assignments here. You may only see today's if you finished yesterday's. Remember, once you complete it, it moves to the complete tab. If it's still showing up here, you're not finished with it. Okay, so you can work on anything that's showing up here under upcoming, yesterday's assignment if you need to finish it first. And then here's today's, the 926. If you have anything showing up under past due, late credit available, that means you haven't finished it. Okay, so the ones from last week, from the 18th and 19th, those are still available for late credit, and you can see they're both at 75% still through the 26th. That's today. So if you have not finished these, one or both of these, I might finish those first, because tonight at 11:59, oh, that one says 10:59. That's a mistake. I'll fix it. But these are going to drop to 50%. Okay, so do them right now while you can still get 75% credit. Okay, the newer ones, the ones from this week have a later due date. You've got all weekend to work on these if you need it. Okay, so I do recommend you finish these first. Okay, if you don't see these here, that means you probably already completed them. You should see them under the complete tab. Any questions about that? All right, this is a great time while you're working to ask questions if you were stuck on anything from any of those past assignments or as you're working on today's. You're welcome to have out your previous notes. You can work with partners or small groups if you'd like. And of course, you can ask me questions. Let me stop this recording real fast.